Good morning, good afternoon, good evening, everyone. So welcome to the ASEAN Group of CIB Webinar 3. Today we are going to have different presentation from our panelists on the theme of smart and sustainable construction. First of all, I just want to let you know that a we have a little bit change of the member of our panel because the Dr. Dimot he is unwell today and he is unable to join us. So we having Dr. Uchenna Ikwi from the Technological University of Dublin, Ireland, as one of the panelists, and Dr. Farah Diva Mustafa from University Technology Malaysia, and Dr. Haro Aquino from Massey University of New Zealand. Thank you very much for your time joining us and sharing your experience and experts on the theme of smart and sustainable construction. So before the presentation of our presenters, let me quickly introduce our CIB ASEAN group of CIB. So you all might know about CIB, right? The International Council for Research and Innovation in Buildings and Construction. So our ASEAN chapter of CIB, we have three coordinator, myself, Professor Rahimi, and Dr. Professor Saraju from UTM. We want to promote the collaboration among CIB member and also among researcher, industry people to promote the research and collaboration in the built environment in the region. And we are organizing the seminar on a monthly basis, and we will share the information on the CIB LinkedIn, and also the session will be recording and later will be uploaded to the YouTube channel of CIB. So thank you very much for everyone joining us today. Let me start with our first presenter, Dr. Haro Aquino from Massey University. Haro, all over to you. Please give us a brief introduction about yourself, and then you can start with your presentation. Let me stop sharing, and then you can share. Yep.
Hello, everyone. I hope you can all see my screen.
Yes.
So thank you, Anne, for that introduction. Again, I'm Harold Aquino. I'm a lecturer at Massey University. I'm originally from the Philippines, so go ASEAN. Um, for this seminar, for this webinar, I'll talk about the topic um, of building regulations as an instrument towards building climate resilient built environment. And I'd say that this is an important aspect of creating a sustainable built environment or sustainable construction in the sense that um, with resilience, we're able to minimize the waste that comes from the impacts of disasters. So, yeah, let me start with a brief background on how building regulations impact the resilience of buildings and structures. So, building regulations are the primary mechanism for achieving resilience in new construction. But the way we structure our building codes, particularly as I'm familiar with the building codes in the ASEAN region, it's historically centered on guaranteeing life safety during disasters. And most of the building regulations among ASEAN countries are prescriptive in nature, with maybe exceptions in some specific areas of the building code in some of the countries like the fire provisions in the Singaporean building code. Now, since we have prescriptive building code, we're faced with the difficulty of changing baselines, primarily because of the swift increase in the exposure linked to rapid urbanization. But at the same time, the baseline also shifts because the hazards are also changing. The way we design prescriptive building codes is we do a probabilistic analysis of the hazards and then we codify them However, if the hazards do not follow a similar probabilistic distribution as they had before, then we have a problem because then our building codes, building regulations aren't responsive to present and future hazards anymore. Now, there are multiple ways by which we can have the building code contribute towards climate resilience. And we'll go through them one by one briefly in this presentation. So the four main things would be provisions on elevating material performance against climate hazards or climate impacts, increasing design loads, making or allowing provisions for adaptable and flexible designs, and finally, green building in incorporation into the code. The most common way by which we design or tweak our building code to make it more responsive to the impacts of climate or climate change is by increasing design wind loads. So I've seen this in my experience in updating the building codes in the Philippines. We've seen in the aftermath of Cyclone Haiyan that the wind zones or the wind zone map was updated to take into account newer maxima. So with increased design loads, what we do is we um, make our structures to withstand more intense hazards as we update the probabilistic hazard maps. So that goes. Maybe some countries would have their own flood codes, earthquake loads, and in the case of temperate countries, we have adjustments in the snow loads. With increased design loads, this also gives due consideration to updated hazard models and intensifying hazards due to climate change. So from what I've seen so far, most of the codes only take into account what happened so far and does not really take into account yet the possible trajectories with different RCPs. So there's still work to be done on that. The second way by which building regulations could be more responsive to the impacts of climate change or making our built environment more resilient to uh, climate change is by incorporating provisions for enhanced material performance and durability. Again, due to climate change, materials now must endure harsher conditions than they had before. So conditions like heat, moisture, even saltwater intrusions, because we get more cyclones, and then therefore you get lots of sea breezes too. And then there's also on the other end of the spectrum, we have material performance provisions for integrating allowance for eco-friendly or durable materials. The other thing is that, and I must say that this is one of the biggest challenge in making structures in the ASEAN more resilient to the impacts of climate change, is that we have strict prescriptive building codes. By prescriptive building codes, we mean that we tell the people how to do, how to create, or how to design structures. And when we do that, we limit the possibilities by which we can configure our structures. Now, if you look at the building codes of most of the Asian countries, you wouldn't see provisions that you can comply with to implement, say, a house that floats with increased flood levels, or maybe window angles changing with the time of the day or the heat surrounding heat in the surrounding environment. So there's still room for improvement in that regard to allow flexibility at integrating adaptation measures um, in code compliance structures. And then lastly, we have green buildings and energy efficiency. So I think this works on the other end of the climate resilience. So green building provisions help mitigate the exacerbation of climate shift by lowering carbon emissions in construction, both the embodied carbon and the operational carbon. At the same time, it also makes the indoor environment more conducive to occupants amid a warming outside environment. Now, building codes not only shape the resilience of the building or the built environment to climate hazards or to climate impact, building codes themselves or building regulations themselves are shaped by the hazards that happen in an area. So, for instance, Jamaica had their first building code implemented in their country after their Hurricane Gilbert experience. So they adopted the International Building Code. In Australia, in Australia, they updated the wind-related structural standards in the aftermath of Cyclone Tracy, which caused heavy devastation in the Northern Territory, part of Australia. In response to Hurricane Katrina's impact, revised building codes were, or the U.S. revised their building code to better account for high winds and flood loads. And in the aftermath of the Canterbury earthquake, the New Zealand building code and standards were reviewed and rewritten. However, not all of these updates or these upgrades and changes to the building codes have been successful. So I would say, and based on reviews, some of the challenges causing us to have still inefficiencies or building code updates not resulting in an enhanced resilience is that there may be the inability to elicit regulatory compliance. So we may have building code, but if the regulators cannot implement them anyway, it doesn't amount to anything. And this stems possibly from poorly planned rollouts, but also it may stem from the lack of knowledge and capacity by building practitioners. So it will take time for building designers, constructors to be able to grasp and be familiarized with revisions in the building code. So it's up to the policymakers and decision makers to accelerate that adoption. It may also be that the building codes that we adopt could be incompatible with the local building stock. And that would be, I would say, that would be the experience of Jamaica after they adopted the International Building Code. But I would say I've seen that also in Fiji adopting the Australian and New Zealand Building Code. But then these codes cater to contemporary structures. But how about the traditional structures like bure? And then the other thing, which is equally as important, is that people may want to comply, but because of budget constraints, because of prohibitive costs, they're unable to afford compliance. And we've seen that in the case of Madagascar updating their building codes. So they've seen a 24 to 104% increase in the cost of traditional housing units in the highlands of Madagascar. And then after Australia implemented changes to its fire protection provisions, after the Victorian bushfires, there was a 30% average increase in housing construction in Victoria. And in the Philippines, when we updated the code to um, when we adjusted the wind zone maps in account of more recent hazard events, there was a 6% increase for low cost housing on the average. Now, we might say, okay, there may be upfront, these may just be upfront costs, but if we look at it on the long run, then we would actually see the benefits. And so in this slide, I just show a quick calculation of the economic analysis from a life cycle perspective. So the cost that we spend, the additional cost that we spend with the building code update is denoted by the left-hand side, alpha C, where alpha is just the percentage increase in the cost, and C is the original cost of construction. And that has to be equivalent to the net present value of the estimated annual loss for the building throughout its useful life. And if we assume a 50-year lifespan for the building, so in most building codes, we have a 50-year lifespan, assumed lifespan for buildings, and a 5% discount rate or interest rate, 1% increase in the construction cost would be justified by a 5.48 decrease in the annual expected losses. So we can do a quick, this equation would allow us to do a quick math on whether the increase in the construction uh, cost would be reasonable. Well, that's just one aspect, obviously, because affordability by the complying parties is also another thing that we need to address. Now, additionally, so in addition to considering it or looking at it from a life cycle perspective, what worked for the Australian case after Cyclone Tracy is that so they introduced specific manual per state. They updated the they also updated the structural standards for when design, but the code upgrade was supplemented by the establishment of the cyclone testing station at James Cook University. So that enabled the grounding of further building code updates on empirical data. At the same time, there was targeted training programs for not only contractors and builders, but also those who would need to do the regular compliance audits or the building inspectors. All right. So let me just say that this is possible, and building regulations, if balance against if balance against the cost or the affordability, and if also balance against the capacity of your building practitioners to implement it, would be a very good instrument towards achieving climate resilience. That's all for my presentation. Thank you.
Thank you very much, Harold. Do we have any question from our audience in the room? Lilinia, do you have any question or no? Okay. All right. So we have one question from HM. Hi, Harold. I wonder how significant the cost of the project would be compared to the typical conservative construction project. Can you see it from the chat
Ah,
box, Harold?
oh, yes, yes, yes. Thank you for the question, Hisham. I would say that is very heavily context dependent. So I've seen in the cases of Philippines and in Fiji, but I've also done some studies in the context of New Zealand. So it varies very heavily. In the Philippines, you get a lot of low cost labor, um, and the materials are a bit cheaper. So if you upgrade the building code from a Category 4 to a Category 5 cyclone resilience, then you would only need 6% increase. But if you do the same for Fiji, which rely heavily on say imports of steel, and also would have a bit higher in terms of labor cost, that amounts to close to 30% increase in the construction cost. Now, injecting the sustainability elements, I've encountered a lot of studies also looking into cost increases arising from energy retrofits in buildings, and I would say that it also heavily varies depending on the technology that you're adopting, and also the specific context you're building it in. I hope that answers the question.
Thanks, Harold, and thanks, Hisham. Is there any other question from our audience in the room? Maybe like while waiting other to come up with the question, Harold, that's a quick one. Like we know that there are different kind of building technique or different material being promoted for building resilience. So do you have any specific like recommendation for specific building techniques or material we should prioritize to improve climate resilience or yep.
It would depend on the primary hazard in the area, because climate resilience, I would say, is still a very broad topic. Climate resilience could be resilience to severe winds, it could be resilience to rising floods, it could also be resilience to experiencing snow for the first time or to extreme heat. So, but it's typically strengthening the building envelope. So that's so for most of it, it's about strengthening the building envelope. But at the same time, for severe winds and flood hazard, we would also need to consider strengthening the structural component of the buildings.
Yep, thank you. I think Hisham also have one follow-up question in the chat box. Yep.
Oh yes, actually, in contrast, based on my case studies, the cost the cost increase is less in developing countries. But maybe if we talk about adopting green technologies, that's where we flip the picture, and it's likely to be that the cost would be a lot less in developed countries.
Yeah, I hope that it answers your question. Hisham, maybe like we can keep a question for Harold at the end. Now we are inviting Dr. Farah from UTM. Farah, are you there?
Yes, I'm here. Hold on, yeah.
Yeah.
And
Yeah. So Dr. Farah is a lecturer at University Technology Malaysia, and now the floor is over to you, Farah. Could you please introduce yourself and start with your presentation? Thank you.
okay, thank you so much, Anne. Good afternoon, good morning, and good afternoon, everyone. So we have several time zone here. I'm from Malaysia, so good afternoon to those in Southeast Asian region, and good morning to those in Masay. Is it morning, right?
Yeah, actually, it's evening.
It's in evening, I'm so sorry. And
Yep.
then those in UK regions, so
Yep.
it's actually morning. I am Farah, a quantity surveying lecturer with UTM. And I would like to share our recently completed research titled Simulation-Based Elemental Cost Model for Smart Living Housing Development in Malaysia. Okay, similar to Harrod's, we would always like to know we know all the benefits of sustainables. Means I'm sure each and every one of us here, we look forward to care of our environment. Okay, but the thing is, developing the environments, the facilities will have some sort of externalities to the environment. But the thing is, by employing all these sustainable features, it adds the cost. So that's why our research, we would like to know, okay, what's the cost implications of employing all these sustainable aspect in our research specifically. We look specifically on smart living housing development. So this is basically the presentation outline, but before we move on, let me give you an overview of what smart city and what is actually the difference between the smart city and smart living. So smart city is actually a concept where supposedly it's an ideal town okay, in response to the ecological, social, and externalities as I've highlighted previously. So in Malaysia, we have started developing our how to say it, standards and guidelines since 2018. But the thing is, because as we are developing countries, we boast certain standards from overseas. We compile it with our how to say it, perspective, and then we add in another one element to build up the smart city aspects, which is the smart infrastructure. Okay, because Malaysia is a developing country, so smart infrastructure, because we still have ongoing infrastructures development in Malaysia. So the thing is, the education standards of the smart city, so they have these education plans cascade down from the federals up to the states and to the dedicated municipals. Okay, and we also have the education standards, as Harold highlighted, the building codes is more or less the same. But the thing is, the focus is more mainly on the townscape rather than the building code itself. Okay, so what is actually the difference between smart city and smart living? Smart living is a subset of the smart city elements, whereby we look into the well-beings of the occupants. Okay, so on top of that, it also a combination of the smart homes smart applications, and we also would like to focus on the quality, security, and healthcare of the residents. Okay, this research actually inspired from my own experience taking care of my dad, but he don't want to live with me. So being a daughter concerning his health, okay, living in another country, in another town. So that's why this research was really close to my heart, because in Malaysia, we are going towards this aging population. And I'm sure for Malaysian, how to say, audience today, we've been actually, how to say, alerted. We've seen recent cases where there are, how to say, people living alone, but and then died alone. So they were only, how to say, noticed by the neighbors upon smelling the deceased, how to say, bodies. Okay, so since we don't have the adoption yet, means we borrow from others. So we look into Singapore's smart living implementations, where it actually focus on the interactive sensors, home management, water and waste management. But consider this, Singapore is a developed country. Likewise, Helsinki also focus on the technology. Okay, smart home solution, renewable energy, but similarly to Malaysian, how to say, characteristics, Bangkok and Ho Chi Minh, Vietnam, it focuses on the how to say, the technical aspects, which is the video monitoring, system lighting, control smart, and of course home entertainment. Okay, the difference between 1 and 2, okay, they are developed countries. So most of the time, they are focusing on the retrofitting the smart living onto the, how to say, conventional building, as opposed to Bangkok and Ho Chi Minh. So whereby we build a new township with all these smart living features. Okay, so upon looking at all the aspects, the features of the smart living, so we categorize it into 3, which is social, economy, and environmental. So you can see all this is actually considered as smart living features, okay, categorized accordingly. And then we further, as quantity surveyors, we would like to categorize the cost accordingly into the elemental. So that's why we have this townscape categorization and buildingscapes categorization. But from the values perspective, when you want to consider the value for the facility, you will always consider the building aspects, okay, rather than the townscape. The townscape, how to say, value comes slightly later compared to the building cost. Okay, so that's why, because we know the benefits of having smart living, the problem always about uncertainties. How much will it cost? Means how much will it impact? So that's why we develop this research using all these problems, okay, the one that are actually as displayed here, and into these research aims, okay, we would like to know, okay, so how much is the cost implication? And when we want to actually delve further, when we want to consider cost implication, obviously we need to know the tools for decision making. For quantity surveyors, thankfully we have this cost model to assist us in how to say, viewing or actually considering what is the cost implication, not only the cost per meter square per se, but by the elemental. Okay, so that's why we want to first determine what is the housing, smart living housing features that is most applicable to Malaysian perspective. The second one, we develop and simulate the cost living housing. And then finally, we validate our smart model cost. So how we go and actually achieve our research, we actually started off with questionnaire survey, whereby we distributed the questions, the questionnaire, and we come up with all these 49 smart living features. And most of our respondents are developers. And then once we manage to get all the smart living features that is considered applicable to Malaysian context, we then go to our cost data analysis because we go for case studies to get our cost data in order to come up with our cost model. Okay, we do the cost simulations. When we've actually managed to acquire all the smart living features, we use Cost software to do our cost implication simulation. All right, and then finally, when we get this data validation, we run through the sensitive analysis to show the cost implications of having more or less smart living features onto the building housing development. So this is our findings. So we are focusing on the landed property first, right? Because actually in our research, we covered two, landed property and apartment. Okay, so if you notice on your right-hand side, okay, so this is actually are the features considered applicable to Malaysian context from our respondents, and then it is according to the elemental aspect. And then when we want to consider the cost implication, we need to know, okay, how many features will have the highest cost implications in order for us to build a house. Okay, so this is actually additional findings that we managed to get through our research. Okay, so we actually how to say imitate this GBI rating tools and put it into this categorization. Because why we need to do this is considered as sensitivity analysis, because the more features you put in, if you want to build a smart living house, obviously it will have, this is the hypothesis, so obviously it will be it will be more expensive, right? Okay, so from the research, we managed to find that these are additional smart living features, okay, again, according to the building elements aspects, whereby you can see the additional items for the superstructure is polarized glass panel, solar panel on balcony, water closet items for the fittings and finishing, LED, and then perhaps for the services, sanitary appliances, the dual flush toilet. Okay, if you notice all these items, okay, you can consider that, we already have this item. But the thing is, there is no standard as how Harold highlighted it. We in Malaysia, we don't have the standard to say that, okay, by having this feature, okay, this is considered as smart living housing. And then, but to what extent? So that's why we did this research. So this is actually how we did the cost simulations. Okay, let me just play the video. Because once we get the cost data from the case studies, okay, so we run through, we design, we have our architect tips to design the housings, and we use this software to do the cost implication. The beauty of actually using this software is that we don't have to build the house yet, okay, with all the features. So we just use this BIM technology in order to do the cost simulations for this smart living housing. Right. Okay. So this is actually the research outcome, the the analysis. So we actually have categorized using the sensitive analysis. We have categorized it into 5 level, which is the certified. We have with the least smart living features, and diamond with the most smart living features. So we compare it with the conventional housing, okay, because we need to know comparison, how much it increases. Okay, Harold just now highlighted the one in Australia for the fire protection itself it actually increases around 30%. So for Malaysia, smart living housing, the cost implication is as according to these slides. Okay, so again, by having, because when you develop a cost model, you need to not only know the features, okay, which is really the drivers. So the drivers of the smart living, you need to know items, the yardsticks, and finally the cost data. So that is actually the outcome of research. And if you notice, so we might manage to categorize to again standardize all the yardstick, because again, from our case studies, developers actually put it into their different kinds of cost yardsticks. So by having a standard, how to say, measurement, okay, yardsticks, we can actually do a proper cost simulation. So I'm so sorry. I don't know why it's actually not moving. Okay. So this is actually the analysis to compare the increments of the cost comparing to the conventional, okay, onto the 5, how to say, levels of the ratings, okay. So we put it into 2 ways of presentations, cost per meter square and cost per square feet, right? And then further to the increments, okay, because from quantity surveying perspective, we want to know which elements have the highest cost implication. So that will make us a better QS rather than cost per meter square increment, but which features, which elements, okay? So we found out that most of the features, considering the smart living element, is within the building services. So you can see it actually increases substantially from conventional, which is 157 ringgit 25 cent per meter square, to 750 ringgit 0.47 ringgit for a certified level of the smart living housing. This is the lowest level of the smart living analysis. And as you add in more features, obviously the increment will be substantial. So we actually conclude our research by highlighting this. The major costs will normally focus on the services, building services, rather than the superstructures and actually substructure. And moderate cost increments is actually in the external works. And then finally, the minor cost increment will be in the superstructure. Okay, so this is actually the cost implication. I don't know why my slide is going backwards. Okay, so to conclude, so whether we can actually afford this smart living housing, okay, the thing is actually it needs some consideration in selecting the features, because in a typical housing development, so we need to consider all these development cost component, hard costs, soft costs, and land costs, and obviously the profit margin. So you can see the increments from the conventional housings to the smart living housing is actually quite, how to say, substantial, and the focus is mainly in the building services. So to put it in a simpler manner, so is it a luxury or necessity? I would actually would recommend that it is actually necessity, but we need to consider which features is more applicable for how to say our needs. It can be luxury, it can be basic features. So this is actually finalized the selection of the smart living housing features as I highlighted previously. So if you can see smart security lock system, that will be considered as necessity. And then perhaps maybe the portable parcel box will be considered as luxury items, okay, to be included in the smart living feature. This is my research team, me, Paradiva, and Dr. Muzani, and Ko Fun Cheng. So this research was actually supported by NAPRAC. Okay, this is actually one of the research institute in Malaysia. Okay, that's all from me, Anne. Thank you.
Thank you so much, Farah. It really insightful presentation, and we learn a lot. I'm sure that the other audience also have the same message to you. Do we have any question for Farah? Anyone, please? We have one question in the chat box, Farah. How can housing
Okay,
developers, yep, and
this
policymaker
is
balance the rapid, yep. So you can read that, right?
okay. This one, how can housing? Okay, let me. From strong Hisham, I think it's actually more for Harrods. Okay, and this one, how can housing developers and policymakers balance the rapid obsolescence of smart? Okay, this is actually good. Questions. From Wu. Okay. In fact, this is actually our incoming research actually, because if you look into the features, okay, some of the features is considered as active design, and some of the features is considered as passive design. So we would like to do this cost implication analysis in terms of looking at the active design of the smart living housing features as opposed to the passive design smart living housing features. Because you can see certain items, okay, the obsolescence in technology aspect, it normally lasts up until only 3 years. So this is one of the aspect that we need to consider. Okay, so but from Malaysian perspective, as if the way developer put it into their, because there's no standard yet, so the way they select the features, they put it in such a way that smart living is luxury items as opposed to a basic necessity. So that's why by choosing features that is actually how to say not IT related will assist in controlling the how to say cost implication. All right. And do you happen to send cost difference when building a new building with all these features? Retrofitting, we have not done it, Survey Zulisham, because our research was only 1 year. We need to come up with this, at least the parameters. So the parameter that we chose is for the new build. We didn't do the retrofit. Okay, I hope it answers your questions. And from Nazim, how can we increase knowledge and use from the perspective of Malaysia? Okay, yeah, we need more, how to say, again, what is the word? Promotions, okay, especially among developers. So that's why I've been working closely with Rehda and Sheda. Sheda is actually Real Estate Housing Developers Association in Sarawak, in order to promote building these more sustainable or smart living housing features, but considering with the minimal cost implications to the developers, because Malaysian housing in Malaysia is actually already expensive, okay, for and Harold and those, okay. So even the conventional house is actually considered expensive in Malaysia. So that's why by having these additional features, it obviously increases the cost. That's why we would like to promote having features with a minimal cost implications so that everyone can actually afford to live in a smart living housing environment.
Thank you, Hara. I think like you already answered all the question, right? So from my my point of view, I don't have any question. It's just a comment. If you can put the increase of the cost for X item as percentage, sometimes it easier for us to remember, like we know.
Understand?
Yeah, so it is a lot of figure, a lot of number.
Yes.
But
Yes.
anyway, it's really interesting research, and we will look forward on for your future finding as well.
Inshallah. Thank you, Anne.
Yes, thank you, Farah. And now we are moving on with our last presentation from Dr. Uchenna. Um, are you here with us?
Yes.
Yep. So over to you. We have Dr. Uchenna from Technological University of Dublin in Ireland, and he will introduce himself and also the topic. Thank you for joining us.
Thank you, everyone. And I'm happy to be here as well. My own presentation is going to be a very simple one, which I know a good number of us are already aware of something similar to what I have done, though it's basically addressing the Irish perspective. I'm Uchenna Igwe from Technological University Dublin, and my presentation is titled Advancing Building Information Modeling BIM in the Irish Construction Industry. We employed a cytometric analysis and also did a survey to do a practical analysis of the adoption trends and the core challenges of adopting BIM in the Irish construction industry. So, as we all know, that BIM is a transformative technology globally in the construction industry, which is currently, changing how construction projects are being conceptualized, how the construction projects are being designed, and how construction projects are delivered and managed globally in the industry. It is a transformative tool actually that is increasing efficiency of project delivery, and it is also helping in cost savings. And of course, it extends basically to sustainability related practices in the industry globally. And Ireland is not actually an exception, in the BIM movement or in the BIM digital transformations in the industry. Basically, in Ireland, there has been a lot of BIM development programs that has actually supported the use of BIM in the delivery of construction projects. And one of the key things that has happened in Ireland at the moment is the BIM mandate, which was flagged off in January 2024. And the BIM mandate is expected that every public project must utilize BIM to deliver their project. And as you can see in the timeline, one of the major publications or one of the major communications related to BIM was actually in 2013, and the most recent is that of 2024, which has to regulate the BIM adoptions in the industry. So it's expected that by December 2027, that every public project that is less than 1 million euros should have adopted BIM. But at the moment, we are still in the second timeline, which is utilizing BIM to deliver a project that is less than or equal to 100 million euros, specifically public projects. So one of the major challenge is still how we can actually utilize BIM and ensure that all the smaller firms are also utilizing BIM, and also how can we define that someone has used BIM to deliver their project in a given project. That is one of the core challenge in the industry. So one of the things that we tried doing in this simple research is to find out how the BIM adoption has been in Ireland, which area has been the use of BIM in the industry, and we tried also to see how we can expand it to looking at how much BIM has been adopted for cost management specifically. So why we actually did the research is that having known that Ireland has adopted BIM significantly, the Rendat is one of the major industry publication, those industry publication experts that has already done some kind of publications with respect to BIM. According to his publication, about 75 to 80% of construction firms in Ireland are already utilizing BIM as of 2023. So that's actually a high number, which means that major companies are already utilizing BIM. Virtually all the industries. I personally went for site supervision when our students were on industrial placement. We can see that majority of them are already adopting BIM platforms to do their job. And most of these firms are currently operating in BIM level 2, where they have to ensure a connected site to ensure that at least most of the digital informations are being communicated to all the stakeholders. And of course, 15 to 20%, according to his report, is transitioning to BIM level 3. And one of the major requirements of the BIM mandate is that at least any industry utilizing BIM should ensure that they are operating on the BIM level 3. And that was actually one of the requirements in the BIM mandate. But despite all this development in the Irish perspective in terms of BIM adoption, it has also been discovered that there is lack of coordinated effort to monitor BIM capabilities and the adoption nationwide. So we are still having an issue on how we can coordinate the BIM adoption, especially on the side of the SMEs. So we need to understand the BIM trajectories in Ireland. We need to understand how the dissemination patterns looks like. We have to identify the knowledge gap and also possibly highlight emerging themes shaping the BIM adoption in the Irish construction industry. So one of the things that we did is to do a cytometric analysis using voice viewer and the bibliographic data that we got from Scopus database, and also sent out a structured survey targeting Irish construction professionals. Let us see what tools are they using and what are they using those tools to do, when they say they're utilizing BIM. And the essence of doing the cytometric analysis is also to see how much the BIM adoption has been communicated, especially those of us in the academics. You can see that we need to understand how much of this information is being communicated in as much as these tools are being used in the industry, how much research has been carried out, and how much has been communicated via major databases, and what we have to do, the cytometric analysis aims to uncover the key research trends in the BIM adoption within Ireland's construction industry and using the VoiceView software. So we try to look at the keyword concurrence analysis, the co-authorship patterns, and the citation patterns. The reason why we choose Scopus database was because Scopus is actually one of the database that is known for its extensive coverage of peer-reviewed journals, conference proceedings, and industry publications. And it helps to offer insights into both academic and professional perspective. We could have used also Web of Science. Google Scholar could have also been useful, but most of the information in Scopus could have also been found in Google Scholar as well. So we had to focus specifically on the Scopus database because those are the major areas we were able to extract information related to research and also industry publications. So we had to target some queries and also have an inclusion criteria of publications between 2010 to 2023. This is when this research was actually done. So we did not really include that of 2024 because we have done this before 2024. So the search queries that gave us the highest number, which is 30 articles, was the one we used to do the analysis. So we also sent out a structured survey targeting Irish construction industries, and one sample t-test was used, and also did a kind of descriptive analysis across Corvallis analysis, to assess the challenges and the barriers to BIM adoptions. So the findings showcase that, before 2013, there has been a minimal activities related to BIM in the industry, or even in the research institutions. So from 2023, that is when there was a kind of a steady increase in the BIM researches and also the BIM related information being published online. And looking at the institutions, the top Irish institutions that is engaged in BIM research, we saw that Technological University Dublin, though this is not political, this is Scopus database, they're showing that at least Technological University Dublin is topping when it comes to BIM research and also publications that has to do with BIM in the Irish perspective. So we had to also generate a voice visualization to show the timeline of key BIM related keywords in Ireland's construction sector. And you can see that the circle size actually reflects the keyword frequency, while the thickness of the line indicates the association, strength between the keywords, with closer proximity showing a stronger relationship. And if you look at that visualization, you can see that architectural design is actually having a higher, link strength of 64. And also we have building information and modeling, though that may not really be much considered, but we can see also the other ones like energy efficiency, construction industry, like project management, also coming into play, and sustainable development. So these are the key areas that few publications might have been actually utilized. What it simply means is that uh, the analysis underscores that BIM's multidimensional focus is actually on architectural design, construction management, and energy efficiency and sustainable development in the Irish construction industry, or even in the Irish um, BIM related researches. And doing the descriptive analysis and also one sample t-test, also showing something that is also similar to what we got from the bibliographic data, showing that the architectural, structural, and map design is also one of the key things that BIM is being basically adopted, in the island. So that is the major area that BIM is adopted, for in the construction industry. And then looking at the challenges, one of the key challenges is we still have issues related to limited skills and training. And we also have things related to neglect on the areas of the small and medium scale enterprises. So, and there has been some kinds of movement in the industry, also in other sectors, trying to see how best they can train the small and medium enterprises to adopt BIM in their in the delivery of their projects. One of the key major thing that the Irish government is doing, that they established an institution where they call National BIM Council, and there is also an agency called Construction IT Alliance (CITA) that has also been carrying out what they call the digital series of webinars and trainings, and also upscaling programs for the small and medium enterprises and other professionals in the industry to ensure that the pace of adoption is increased in Ireland. So BIM adoption in Ireland is actually advancing, but it is uneven. So we have one of the major things that we actually did, we suggested, is that we have to strengthen academia and industry researches on energy modeling and life cycle costing. Especially, I carried out a similar research sometime that has to do with cost management, and we saw that BIM is actually very much relegated when it comes to cost management in the construction industry. And especially those involved in the cost management and quantity surveyors, we need to actually be, up on our games. So we need a coordinated training, standards, and monitoring to ensure sustainable digital transformation in terms of BIM adoption. So this is my presentation. It's just a very simple one, and I hope you can ask me also a simple question that I can answer. Thank you very much.
Thank you, Uchenna. So we are open the floor for question from the audience. Is there any question? You can unmute yourself. Haro, yeah, please.
No, is this clapping?
Okay, I thought that you have any question. So while waiting for other having, typing the question in the chat box, I just have one, like I mean like it been introduced for a long time in Ireland, right? But it's just recently mandate in 2024. Is that
Yeah,
right, Uchenna? Yes. So is there any reason for that long time until
uh,
2024 being mandate?
well, it has always been, before the BIM mandate, there was what we call the roadmap that
Mm,
was actually introduced in 2010 by the
mm,
National BIM Council. So the roadmap was towards flagging of the BIM mandate,
mm,
actually. So the BIM adoption in the industry has actually been there. Most of the industries has been utilizing BIM, but there is no regulation, there is no policy, there is no governmental involvement to ensure that this digital tool is well utilized. So what the Irish in government did was to look at what UK is doing, look at what Finland is doing, and they have to, we are just neighbors. So we have to ensure that we are not left behind. We have to follow the trend. So they started by looking at what UK was doing, and then they flagged off the roadmap in 2010, and then gradually tried to introduce BIM in the public sector project. And they started announcing the BIM mandate from then till 2024, when it was finally, made public and it was
Mm.
made mandatory for every public project.
Yeah, and I think it might be quite early, but do you see, like, have you seen any outcomes or benefits observed since the bean mandates were introduced in Ireland? Is there any, like, it quite might be quite early. It's just nearly a year now, right?
If it was flagged off earlier,
Mm,
yeah, I think it could have been, there could have been some kind of benefit, because before now, maybe by this time, most of the industries, especially the smaller industries, would have
mm,
also been carried along.
yeah.
So, but because it was flagged off a bit late, most of these industries, nobody cares about BIM. They just want to go do their jobs traditionally, you know, and so many are already outdated tools that they are using, and some are not willing to change. And
Mm,
most of these industry practitioners are aged. So asking a 75 or 60-year-old man to come back and start learning some digital tools may be a no-no for them. So they may be finding it difficult to come back to learning some of these tools. So
yes.
if it was flagged off earlier, it could have helped these medium, smaller firms to adopt BIM.
Yep. Thank you. Harold, is that the real
Well,
question now?
yes, yes. It's
Okay.
related to Anne's question too. I was wondering if you have information on how effective the mandate was. Like, was there a big jump when the government mandated BIM use, or it was insubstantial? And I think that also points to the type of mandate and the corresponding sanction that the government would impose for non-compliance. So what do you have insights on that?
Well, that's actually one of the key things. We actually need to ensure that this is properly enforced. But the government is doing their bit, so like if you look at the timeline that I shared, the first site was in the first 12 calendar months from January 2024. It's expected that every public project that is above 100 million, from 100 million euros and above, must utilize BIM. So there are notable projects or notable companies that have tried to ensure that they comply to that. Like BAM UK, they have John Sesk. There are bigger projects in Ireland that is currently ongoing, which of course the eye of the government will definitely be there. So they will definitely ensure that they comply to the BIM mandate. So ensuring that all the digital tools, and for every professional like the QS, like the architects, there are minimum requirements that can define your use of BIM. So one of the, like those of us in the quantity surveying sector, it's expected that we use ISO 19650, to be, our cost management should be in compliance with that, and also utilize what we call the ICMS, for the cost reporting, so those are the key things that the BIM mandate actually enshrines. So those key projects that's above 100 million euros, it tries to comply to those basic things, because that tries to monitor as well. It has been effective so far, but there are still some kind of challenges.
Thank you for that. And is there any other question? I don't see any question in the chat box. And Now the time is off, and once again, thank you very much, our presenter, Haro, Farah, and Uchena. Thank you for your time joining us today. And also thank you to the audience with your attendance and also your question to our presenter. Hopefully, we'll see you all in our next webinar in July. And just want to say goodbye for now and have a good day, have a good night, everyone.
And can perhaps
Yep.
a very quick photo
Yep.
session?
Yep.
For Momento.
Sorry. Let me try. Haro, can you help with that?
Nice. I think I just need to screenshot, right?
Yes, yes.
Okay,
Just
but
screenshot
you need to put everyone on the
in one
screen.
frame, yes.
Yeah, I think everyone's on a
One
single
frame,
frame,
yes.
so we just need to get
Well,
everyone turned on there.
View and I think gallery. Okay, I got it now.
Do
Smile, everyone.
everyone need to turn on their cameras?
Yes, please. If you
yes.
can turn on your camera, please. Okay. Smile. Oh my God. I don't know if I do it properly or not. Farah, if you want, or let me stop recording now first.